So good.
Oh well.
Oh well. We are going to finish these, and then tomorrow we're going to practice them. Thursday review, Friday test. Okay, yeah, I know. So first of all, do you know the formulas you need to know? There are two formulas you must have memorized for this test. And including Hunter, who is normally going to calculate or button it, he still going to have to prove he knows the two formulas.
Come on, Hunter.
One involves means and one involves proportions. Oh, Lord. So the one we've been using before we started yesterday's notes was the one involving p-hats because we were dealing with proportions. So when we were dealing with proportions,
Hey, settle down.
can we do that now, please? Okay.
Settle down.
Uh-huh. Yeah. So when we were doing proportions, we needed to know, and of course, she's right, we needed to think z-star. So that was the one that had the p-hat, plus or minus z-star, square root of p-hat, 1 minus p-hat, plus u, all divided by n. That was the one you need to know for proportions, but as of yesterday, we started talking about what if it was means, and that's when we have to use t-star. And that's when we're going to start having X bar. And if you need to look back for that one, you can. If you look on your notes on the page before.
X bar minus u, X bar minus u, over Taylor's distribution.
You don't have to know the t equals 1. No, I feel like that one is kind of intuitive. I don't know.
Because that's the one that might be useful.
Yes. That literally, because they gave you the standard deviation of the population, you have to divide by the, yeah. Does someone just want to tell me what's going on as to why, like, 1 and 2 are on my last nerves? Okay. Like, are y'all okay?
All I do is express my love for vegetables. I go with that.
You should.
Wow, okay.
Are y'all okay?
To get my personal right.
Okay. Well, we'll turn on my ear.
Thanks. I need that one.
Is this your prom
Okay. Yes. How lovely. Okay.
Oh, nothing.
So let's do math. It won't take long if we do it. The second formula is the one we got yesterday. And so Kinsey on her way out was asking, hey, do I not have to memorize the one about t? I think that one's intuitive, to be honest. And do I think they'll point blank ask you about t? No. They're really going to ask about the t star. Do you need to know where t came from in order to get the t star? Possibly, unless of course you understand how to use your table and how to use your calculator. So if you understand your calculator button pressing, then no. So literally the two formulas you need are the one with the p-hat because proportions, and then of course this one with the x bar because means. So x bar plus or minus t star. But this formula, instead of having everybody under the square root, it only has the n under the square root. So it's sx divided by square root of n. It is on the page before at the very bottom. The page before, so page 6 at the very bottom. So there's a test on Friday. Do you know your two formulas? You need to, like, literally, you must know those two formulas in order to be successful. In addition to knowing those two formulas in order to be successful, you have to always do what when you're given a problem? The first thing you should do before you try to do math is do what?
RIN, that thing.
You should check the conditions, and what are the conditions?
Random.
Normal.
Normal.
And
the I thing.
Independent.
Yes.
So if you don't check those 3 conditions before you do math on your free response, you're not going to get the credit you want. You're probably going to get an I, because how do you get to do the math unless you show that we've met the conditions in order to do the math? So you must check the conditions. That's when we came up with that space stick acronym, but Lord knows it's not sticking. So again, have you checked the conditions, do your math, And then what Shalia and I were discussing yesterday, at the end, you end up writing a sentence. But the sentence part's not that big of a deal as much as the check the conditions, do the math. Okay. So with proportions problems, we're given percentages. With means, they normally give us a mean or a standard deviation or something of that sort. We did not talk about this, and I'm going to briefly say what's in this little box. So there's this thing called robust. And we talked about yesterday that T-stars are technically different. Like a T-table is technically different than a Z-table. A Z-table is that standard normal curve we've been using over and over and over again. A T-table is not quite the same. And that's why we have this degrees of freedom, which you do need to know, and I didn't write that. And we talked about that yesterday. How do you figure out, in order to do a T-star, you're going to have to look at your table. You use the confidence level they give you, like they say we're 95% confident or whatever percent confident, but you also have to calculate the degrees of freedom. How do you know the degrees of freedom?
Well, you do the number minus 1.
Yes. Yes. So it's literally like if there are 20 in our sample, the degrees of freedom is 19. If there are 30 in our sample, the degrees of freedom is 29. It's always one less. Perfect. Okay, so anyway, there's this problem, a part in the middle that says an inference procedure is called robust. Robust. If the probability calculations involved in that procedure remain fairly accurate when a condition for using the procedure is violated. Okay, you don't need to know that word. You don't have to know robust. But again, that's the whole point of the conditions. When it says that a condition for using the procedure is violated, let's say you did not check random. It wasn't random. It didn't meet the independence quality. It wasn't normal. Then maybe you do the math anyway, but your answer might be sort of close because of this robust feature. But again, anytime I don't meet the conditions, I put a little note. Conditions not met, but continuing on. Like, when we don't meet the conditions, life is, can we actually trust the math we're doing? It turns into quite the debate. Okay, so the problem we're going to work today, and there are like 2 other things we're going to talk about. I swear we're going to finish the notes today. It's going to be great. All right, it says, someone who likes to read. Jackson, read.
Starting out a manufacturer.
Yes, please.
A manufacturer of high-resolution computer terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen.
Oh, Lord.
Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process. Here are some tension readings from the random sample of 20 screens from a single day's production. I did so good.
And then read the last sentence for me.
Construct and interpret a 90% confidence interval from the mean tension view of all screens produced on this day.
Okay, perfect. So, the literally who cares about the screen part, there are 3 main things I got from this. How do I know this is a means problem? It literally said the word mean. Okay, there's some numbers that I need from this. What are the numbers that I should gather? Besides the little list there, what else do I need to know?
The 90% confidence interval.
I do need to know the 9% confidence interval.
10% on both sides of the thing.
Yeah, yes, I agree with that, but there's another number in here that I'm going to need.
20 screens.
20 screens, which means n equals 20. And so if I'm thinking about my degrees of freedom is 1 less than that, so 19. Perfect. So again, I like to go ahead and list some stuff, think things through, because it's 20. It's always 1 less than how many is in your sample. How do you know what, Shalia? Because anytime I know I'm doing a means problem and we're dealing with confidence intervals, I know it's going to be a T-star, which is why I know it's degrees of freedom. Again, we're going to practice a couple. You're going to get the hang of it. I swear in half a second after we check the conditions and you were trying to do that math and use that formula we just wrote down, the X bar plus or minus, you would have realized, hey, there's more stuff I need to know. Miss Compton's just done a couple more problems than you, so that's okay. Okay, before we can actually roll, we've got to check these conditions. Okay, and then And it doesn't hurt to write a sentence. Again, Shalea's just trying to get prepared for the end, so I appreciated her questions yesterday. And the textbook suggests maybe the sentence you're wanting to write at the end, go ahead and writing like what are we wanting to know sentence now. So we want to know what. What are we trying to figure out in this problem? Okay, we want to know the true mean, because we don't know the true pops mean, so true populations mean. For, he said, of all the video terminals produced this day. I like that. Video terminals? Is that what it was called? Yeah. And do you have to write the sentence to begin with? No, but Shalea's trying to get ready for the last step. Sure wouldn't kill us to go ahead and think through what are we wanting to know. That way when we phrase our last sentence, we don't have to overthink our lives. The true population's mean of all the video terminals produced. All the screens produced this day. Produced this day at a 90% confidence. And since I'm not actually giving an interval yet, I don't call it an interval yet. I call it a... What do you do when you actually know the range of values for the end? You don't call it a confidence interval, you call it a confidence level. Thank you. Okay, and since we're refreshing on confidence intervals, what does a 90% confidence level or confidence interval or whatever, 90% confidence of what? What does 90% mean? We're 90% confident when we find this interval that our mean is in that true, is in there. The true mean in the population is in there. So doesn't that mean we have a 10% doubt?
Yes.
That we haven't hit it at all? It's kind of scary, but that's okay. As is stats, we're never 100%. Yes, this is absolutely it, because then we would be in calculus. Okay, so we need to check the conditions. Is it random? How do we know? Random sample. It says the word random. Agreed. So I would say given. Given in. Or just if you want to put a sentence given in this scenario, whatever. This is what Shalea's been dying for. It's just given. Because she did not. Because you remember the hearts one, they didn't actually tell us it was given. So we had to assume some things on our part that the conversation hearts were randomly distributed and that kind of thing. So we really like it when it's given. Okay, and then independent. We were doing, when we were doing proportions, we were doing that n times p hat, is that greater than or equal to 10? And the n times 1 minus p hat, is that greater than or equal to 10? But are we dealing with proportions today?
Yep.
No, so this independence is not going to work for us. So what do we need to use in order to prove independence? We would love to use the central limit theorem, but we can't because
There's not 30.
n is not equal to 30. We don't have a large enough sample. We can't actually use the central limit theorem.
CLT then says.
So we can't actually use the CLT because n is not greater than 30. So we've got to come up with a third way. So we'll come back to that one in just a second. Say what now, ma'am? I think this is normal. Thank you, bless you. I think that's what you were saying. This one's normal. I gotta get my life right. Independent was the sample size one. And Shalia and I were debating this yesterday. Actually, no, it was Kendi. We were talking about sometimes I get confused. I know the 3 things I need to check, but I forget which one's normal and which one's independent. I literally would just put the word conditions and then show 3 things. Given random, here's this, here's my math. I know that's terrible, but maybe not labeling it if you're unsure is a good idea. Okay, so independent, we're supposed to show something about the population size. This is how my lady keeps writing it. Don't care how you write it. All that matters is you take your sample, you multiply by 10. Is that less than or equal to our entire population? So is 200 less than or equal to our entire population of video terminal things?
I would hope so.
So we're going to assume population is larger than 200 video terminals. And I get we're making a lot of assumptions, but this is for something that has to do with a viewing screen, and we know a lot of people have TVs, so maybe you want to say something a little smarter and be more of a pain in the butt about life. Okay, but again, so yes, we're happy with random. Independent sounds good. Normal, we are not happy with. We need to be happy. So since the central limit theorem failed us, and we're unhappy, but we have all this data, is there some way we can use this data to prove to ourselves that, again, we don't know about the population if it's normal, but can we somehow prove using our calculator that our sample is normal? I need you to go way, way back in your memory. So stat, I go to edit, I look at my L1, I have it all typed in. Is there somehow I can use that list of points to prove to myself that that list, my sample, really is normal? Now what should I graph? What should I make?
It's the graph. So, yeah.
Let's make it box plot. So second, stat plot. We're going to turn it on. Which one do I pick? Do I pick the fourth or the fifth?
Oh, 4.
Why do I pick the fourth?
Those are the thingies.
Yeah, it's got the outliers, so if we can see the outliers, then if there are outliers, then are we really normal to begin with? So we really need to check this. So I hit that, I hit graph, and what if it doesn't show up then? Mine showed up because I have it zoomed, but what?
Zoom 9?
Because it's zoomed stat. So make sure you zoom stat, or else you're not going to see anything.
There are no outliers.
Okay, I get it's not perfect. I get that Q1 looks a hair larger than Q3. But does it look pretty normal? Like it looks pretty good? Like, does this box plot give us reason to doubt the normality of our graph, of our data?
I clicked the box plot thing, but it's just graphing 2 lines.
Press Y equals. You used this in another class, didn't you? Do you have everything cleared out in here? Okay.
What was it?
Okay, and then so once that's clear, when you press graph, it should just be your box plot. You might have to resume to stat zoom, which is stat now. It's 9, yes. Zoom and then 9 for stats, and then it zooms in for us. Okay, so you and I agree that this looks pretty good and pretty normal, but again, we're trying to convince other people too, so we do have to put this on our paper. So how can I put this graph on my paper really quickly? How do I get the numbers from this graph to my paper really quickly? Trace. If I press trace, I know all the 5 things I need to know. I know the min is 233.5.
Not why is it that? Why is my calculating different?
My Q1 is 275. Do you need help with it?
I don't understand what's happening.
I'm not a teacher.
Oh, press second format. Do you have your coordinate grid? Do you have your grid off?
This is grid on.
Then you turn the grid off.
This should change everything. It changed everything.
Does it now look like this?
Yes.
Okay, perfect. So 275 for the Q1. So trace, got the Q1. The median is 308, 8.85. And then my Q3 is 337.45. And hopefully yours looks a little less jankety than mine, because mine is looking pretty rough today. And then my max is 374.6.
What does that mean?
Again, since it does look like, it looks pretty split in the middle, right? Pretty split. It might be a little more. I did a terrible. Yeah, I did a terrible job drawing up here. Did it look a little more like that line wasn't quite in the center? Yeah, but was it close enough that we're not doubting that it's a normal distribution with our sample data? Sure. I mean, it doesn't look super skewed. You know, it could look, don't freak out, it could look
I don't like that.
like this. Or it could look
Oh, okay.
And here we go again.
I still don't like it.
like super, it could look really janky. It could look really messed up and us question why. But since it kind of looks like the normal one we want, I mean, I agree the line is a little further right than I would like, but there's no reason for us to doubt the normality. So literally, I am going to write a sentence just because I'm a sentence writer. Probably drawing that picture and saying assume normal is okay, but I'm a sentence writer, so I'm going to put box plot gives no reason to doubt the normality. So I'm going to write a sentence to go with it to explain further like why the crap I drew a box plot. So if there were a problem and they give you this long list of stuff, now we're like straight up, I told you eventually all the chapters would tie together. Now we're straight up going back to chapter 1 of maybe that 5-number summary could help me out and prove, hey, maybe for real this thing is normal. So sadly, I've written all over my paper and all we've done is conditions. We've yet to actually do the math part. Oh, fun times. Okay, so I'm running out of room. We read our sentence, we checked our conditions, and now to do the math. We're going to use the formula x bar plus or minus t star. We need that standard deviation over the square root of n. Okay, and that's great. And I know what to put in for n because my sample was 20. But they didn't tell us x bar. They didn't tell us sx, and they did not tell us t star. So where am I getting these other things from?
You can go one variable stats. Get some of them.
You can get a standard
For x
deviation, right?
bar.
You can get the x, y, and the sx, yeah. So if we press stat, calculate one variable stats, again, we're going straight up chapter 1 stuff now. Yep, I've got x bar. That's a lie. I do have x bar. It's 306.32. I just have to ask my calculator for it. Okay, and I even have sx as 36.21 I'm going to put down because it says 36.209, so I said 36.21. But seriously, because you and I typed in a list, and that's the list we're using, our calculator can calculate the mean and the standard deviation we need. And we have a graph. So I really like means problems when they give me a list, but sadly, are they going to probably do that kind of a thing on a free response? Not with this large of a sample because there's a typo. Again, Sally might type 327.3 instead of 327.4. They'd have to have a whole special rubric for her being special. And that's why this is kind of, even though this was easy and I can handle this, more than likely, not. They're probably going to give you the x bar and the standard deviation. Okay, is everyone cool on where I got the 306 and the 36? Now we got to find that t star. So I've got two options. I can pull out my formulas and look at my formula thing. So where are you formula page thing? Hunter, give me yours so I don't have to dig in my line.
Your formula?
Uh-huh. Kind of long. It's just one long. I know, yeah, I need the things. This is not a base, I need the T-star.
I found them. I have them.
T-star, that's
I have all the things. You can get
that's x bar minus mu over standard
All the
sample
things.
divided by-
But I want the table.
Okay.
Okay, so I got my T-star table out. They told us degrees of freedom is 19. We decided it was 90% confidence level, so I can look at my thing.
Wait, why is that?
Because 20 in our sample and degrees of freedom is one less. It's got to do with in life. So I can remind you. So it's got to do with this fact. So right now I have 4 pens to choose from, right? And then once I select one, I have 3 pens to choose from. And once I select one, I have 2 pens to choose from. Do I actually have a choice with the last one?
No.
No, that's why it's one less. Because when I get down to the end, I don't actually have a choice for the last one. Like, I have to use this one. So that's why degrees of freedom is one less thing in your sample. Because on the last one, you have no other options. Okay, so our degrees of freedom is 19. And we are, what confidence level? Is it 90? So I look down here at, God, yours is terrible. Are all y'all's is terrible? Y'all need new ones then.
That's a good idea.
Straight up dead. I'm going to give him a new one tomorrow. 1.729. 1.729, is that what you got when you got the calculator? Yes, right answer.
Yep, that's what I got.
Okay. Okay, so I don't know why I'm handing this to people. That's mine now. Haha. Great. And good for me for plugging all this stuff in. Aren't I awesome? Look at me knowing where to get all this stuff, and I can give you the right answer, and it will be awesome. And I can type in square root of 20, and then 36 divided by that, and then 1, and then plus or minus. Like, I am confident that I can type this in. If you are not that confident, wouldn't it be so much nicer if we could just make the calculator do this whole darn thing for us?
That would be real cool.
And then, so yes, you and I just went to one variable stats to figure out this piece and this piece. Doesn't the calculator already know that? Doesn't the calculator already know the 20? Can't the calculator already do a T-star? So are you surprised that the calculator can do this whole thing without us writing anything down?
Not really.
Not really. We just need to know what button to press on the calculator. So if you got your calculator, we've been doing, you don't even have to inverse T it. We've been doing a one prop Z test, yes, and today we're going to do a T test. Literally, I don't know how you knew that. I had to look it up earlier to make sure it was a T test. I don't know why you're such a genius for calculators.
I just looked 2 T's. I connected by T's.
Okay, so literally, if you look on the next page of your notes, because we cheat, it tells you that if you're wanting to do this on your calculator, which you should want to do on your calculator, because again, we've already typed all the things in our calculator. Our calculator already knows all the answers. Why not just make the calculator do it? If you go to T-test, so stats, test, and then it says T-interval. Ha 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 ha.
Oh, you said T-test, though.
I lied. It says T-int. I can read. It says T-interval. So if we click it, we do have a problem now. It's further down. It's 8. We have a problem now. It says data or stats.
Well, it should be dead.
Well, yeah, it's. I can see how we can argue it's both, but again, we typed in a whole list of crap, didn't we? So don't we have a list of data?
Yeah.
So let's leave it on data. And didn't we type in an L1?
Yeah.
Okay, and then our confidence level, is it 90%?
Yeah.
I don't know why my calculator knew I wanted 90%, so if yours does not have 0.9 there, you need to change it.
Magic.
Then change it to 0.9. And then if you press calculate,
You get a bunch of numbers.
not only does that bad boy, so again, back to my previous page, not only does that bad boy tell me the answer, as in it tells me the range I wanted, but hot dog, it told me what I thought X bar was of the 306. It tells me the 306. I thought SX was 36.2. It tells me the 36.2. Like, stupid calculator does all the crap for me. So why do I even have a brain? Literally, if you, I feel like you could pass the AP Stats test if you could put words together and if you knew what calculator button to press when.
That's just about how I'm going to do it.
So, I don't know. It's just hilarious. So, the answer we got was 292.32,
What if we're off by 100?
320.32. You're going to be okay. They allow for rounding error. Again, our confidence level of 90%, we're already assuming we're 10% wrong.
you go above 100% on a total confidence level?
No. But you know what I mean? Like, we're already assuming we're 10% wrong in life. Why not assume that some of that wrongness has to deal with us around me?
Yeah.
Okay, so we got this number, great. So now we're like Louise, yay, we did math. Again, unless we put a final sentence together, tying that to the 90, we're not done. So yes, we've done all the things, and yes, I'm stinking out of room, but I've got to write a sentence tying it all together. So my sentence, I need to say, I'm 90% confident. And what am I confident of? I'm 90% confident, and I'm spitting back that exact sentence she said, which is the sentence we wrote earlier. So I'm 90% confident I found that true mean. And I'm 90% confident that the true populations mean, and then what the mean was for of all the video, blah, blah, blah. Because if you don't spit the stem back to them, they think you can't read. All the video terminals produced this day are between 292.32 and 320.32. In fact, shouldn't I change that?
Probably.
Why would I want to change one tiny thing?
Because obviously,
No, I'm not going to say it this time. I was thinking about rounding to the nearest whole number
yeah, I was thinking of that too.
because I was thinking millivolts, but again, they gave us a list of millivolts that were decimals, but they only went to one decimal place, so maybe I should go to one decimal place. They're not going to cut off on this one at all, but you realize if we were talking like people and you gave decimals at the end, that would be a problem. So as long as you're not doing people or humans, decimals are fine. If we're talking like cows, then don't do 292.32 cows. Actually round to the nearest whole. I get you can technically kill that. I understand. I'm just saying. I understand.
Slaughtering of 2/3 of a cow.
I understand. Okay, we are going to come back and work this. This is going to be our last example in just a second. It's going to be just as much fun. In fact, it's going to be a little easier. We'll come back to it in just a hot minute. I do want to say some other words before we do that one. Do you know how we discussed this margin of error the other day?
Yeah.
While that's great, and the more I read about it, like, it's great for like a big girl college level stats class, and that's awesome. You don't need it for high school stats. Like, again, like, sorry.
Well done.
I know, right? I mean, do you actually ever know all the things? Like, he's learned Rolle's theorem in calculus, but can he derive it on his own? When, does one ever actually know all the things? Okay, never mind. He doesn't know Rolle's theorem, so therefore he can't. Mean value theorem?
You will only.
Yeah, yes. It's 2 L's and an E. Okay. Back to margin of error still has to deal with in life. If we were wanting a certain confidence level, could we pick a certain a certain sample size? I'm pretty sure you could BS your way through something if they asked you. So I'm gonna do that. Which means I'm gonna do that. Your book kind of does too. It's kind of like, that's great. We don't really need that in this class. Okay, and then I'm still kind of mad at the bottom too. And let's talk about why I think this is stupid. And in fact, your book, like the notes even acknowledge that in just a second. All the math we're doing is us trying to, in this chapter, with the confidence levels and everything, is us trying to predict stuff about this population. Like, we don't know anything about the population. We're not sure. So if we knew the standard deviation of the population, why are we doing confidence intervals and stuff to begin with? Don't we know the true answer? So what is the point in the math we do?
It literally says, but just for your knowledge, if for some reason you're given this
Yeah, just for your knowledge, if for some reason they didn't tell you the population standard deviation or they told you the population standard deviation and not the sample standard deviation, if we knew that, we wouldn't need T's. If we didn't need T's, we would just use Z's. Duh. I understand, but if you look on the next page, it's like, again, for practical purposes, and I'm a very practical person, practical purposes, why would we ever do a confidence interval for means? In theory, we would never know mu without also knowing the true mean. How would we have been given the standard deviation if they didn't know the mean to begin with? Like, you have to know the mean to calculate the standard deviation. And if you know the mean, then why the crap are we doing this math where we're like trying to hypothesize the mean is between here and here? We already know the answer. That's stupid. So forget the last page too. So back to the one problem we need to work about pollutants. Okay, read it through. Why do I know this one is a means? It does give you mean and standard deviation. And it does say mean amount again. So I know my mean. My X bar, they told me it was 1.2675. They told me my standard deviation of 0.332. They told me 95% confidence interval, so confidence level. They told me a sample of 40. So my degrees of freedom is one less than that, so it's 39. And you're like, okay, great, let's roll, because I've got all the things. Agreed. I just write the sentence at the end, but me and Shalia are being perfectionists about the sentence. So if you wanted to ask yourself, what do I need to figure out what we're trying, or maybe just underline it. What are we trying to find? And we want what do we want to know at the end? And we want to know the amount of emitted by light duty engines of this type. So our goal is to find the true mean amount of NOx emitted by light duty engines of this type. So if you just want to underline, hey, P.S., I need to use that in my sentence at the end, that's fine too. I really don't care. As long as you check the conditions, do math, and write a sentence, I'm really not being that picky in life. Literally, yes. Okay, but before we can do the easy math that's going to be required, we need random, independent, and normal. How do I know it's random?
It says random.
It literally says it. Okay, independent and normal. She's like, I like doing normal first. Independent are the 10 times my sample. Is that bigger than or equal to, less than or equal to the whole population? My sample is 40. So is that less than or equal to the whole population? So is 400 less than or equal to what? What is our population? Yeah, light duty engines of the same type. So light duty engines. So I'm going to put light duty engines of the world because I'm a smarty pants. Okay, and then we want to prove normality. Did they tell us anything about being normal?
No.
So how are we going to prove it? This one is easy. No, this one is central limit theorem. Why?
Because it's greater than 30.
Because 40 is greater than or equal to 30. No, I said it wrong earlier in class. That's why we fixed it. I don't know. Why you got me holding these my whole life? Independent, no, independent is the 10 times thing. Normality is the CLT.
It says normal is CLT. Alright, that makes sense.
It says normal,
Yeah.
40 is large, at least 30. Yeah, it says normal CLT, independent 10 times to 40, yeah.
So is
Literally looking at the textbook key, because that's kind of day it is.
So is random the n times p is what is that?
That's still normal. That's normal. We're doing the same thing for random and independent. The only thing that's ever changing is normality. Again, I probably wouldn't even put the words besides random. I'd say random given, and then here's some other things. I check the conditions. Moving on with my life. Okay, but I'm lazy and we're running out of time. So while I could deal with this, sure would be a lot easier to just put all this junk in my calculator. So yes, I know it's supposed to be X bar plus or minus Z star, and it's supposed to be, it's T star. God bless you for realizing that. Any other mistakes I can make today? Sx over the square root of n. And I know that I can figure all this out. I've given my X bar, I see my Sx, I know my n. I just got to figure out my T star, but that's easy because I know my degrees of freedom in my my confidence level. So this should be easy. I could do this. And then the T star I can figure out. I've got my thing. My degrees of freedom is 39 and 95%. So this is a good moment, actually. Thank God. So 95%, and I don't see 39 on here. You actually round down. Down. And I wouldn't have thought that. I would have thought round up. Well, we actually round down. And then, of course, you know what it suggests. So I want to do 2.042 because I am a, you would like it if I zoomed in, because I am a chart referencer person. But in this moment, when it's not actually shown on the chart, wouldn't he be a little more accurate with his stupid calculator button? So he could press the stupid calculator button. He could press inverse T and figure this out. So if you wanted to figure out just that, because you want to calculate the rest by hand, you could use inverse T wherever my calculator went. It ran away. Or if you wanted to do all this at once, if you went to stats, of course you do, tests, of course you do. We would actually, instead of data this time, we would press stats, but you and I know all the things. So we literally could type in this list you and I wrote is going to go straight into our calculator, and our calculator will give us the answer. And that's the end of the story. Okay, I'm going to skip B, and we'll just deal with it. We won't deal with it later. Let me tell you the moral of B. So what happens, which is what's going to happen to you on a free response in the near future, I'm sure, is that, again, we get this interval of where we think the answer is, and what if they give you a number that's outside that interval, therefore we don't believe it's true because it wasn't in our interval. So, like, if we say that 80 to 90, or 90, we're 90% confident everyone in here has between a 90 and 100 average, and then we say, well, so-and-so has an 85, well, we're like, no, we reject that because our range was 90 to 100. I did reject your average, but seriously, I think everyone in the room has 100 because